Hi all, welcome to my channel. So in this video, I'm going to share you about rate limiter low level designing, machine coding round. So I will talk about high level designing and also how to implement this particular high level designing into low level designing. So before that, a small introduction about me. So myself, Lavakumar, currently working as a senior software engineer. Um, so whenever I was giving any interviews which contains any important questions or any machine coding questions or any low level designing, I consistently sharing into my channel. You can subscribe to my channel and click on you can click on bell icon for future videos to get in. This is my low level designing playlist where I have uploaded a lot of low level designing and machine coding questions. If I upload, so previously I have given interviews to Flipkart, so I have uploaded what are the questions they have asked, and also I have applied to Misho also. So whatever the questions they have asked, I have uploaded in my channel. So these are all different questions which I got in my previous companies, and also most important questions also so. And also I have some other videos also where this is those are more related to the interview questions of different companies. So without any further ado, let's start with our today's agenda of discussing about rate limiter. So I think right, like the basic definition of rate limiter is restricting unusual behavior from users, clients, or basically let's say you have an application where it will serve such some it will serve, let's say, addition of two numbers. uh, so um, so that is a, let's say, it is a free application, right? You just launch it for you just launch it for trial phase, but those the URL which have access to any person, they can easily hit the URL and check the results, right? So let's say you have like some certain SLAs are there, your service can only maximum tolerate, let's say, 1,000 requests only, per hour, or let's say only 5 requests per second. So if different users concurrently trying to hit your API, so your API cannot your service cannot handle that much load. It will easily crash the service, right? So its service become unavailable. So one thing you can do is like restricting the user to like to add one more layer without to add one more layer. That layer is basically checking the user privileges. Like, okay, this user particularly have some certain configurations to access our inside systems. If that is not if that is breached, like that user, we need to show the error message like 403, services are busy, or simply rejected the request, or put it in the queue for to check later, to serve the request later after some certain seconds. So mainly, like, users will try to some different bots will try to keep on hitting our requests. That is the main reason our service will become easily available. So that the rate limiter, also called as throttle service, will help us to handle such load efficiently, evenly across all the clients. So first of all, let's talk about the problem. So this is the problem. In the first design, like, client serves the request. We have our gateway service. So multiple requests keep on coming from different clients. So let's say single client at a single client, let's say they did some for loop. Let's say in I equals to one, let's say 0 to 1,000, or concurrently execute 1,000 threads at a time to just hit our API itself. So our system is like might cannot serve other users also, because of that single client is keep on doing unusual activity on our website, right? So our system might crash. So the thing is, like, we need to implement something filter mechanism, that is nothing but a rate limiter. So this is the basic high level designing of rate limiter. This is very basic high level designing. I'm not talking about in depth of high level designing of how to scale the system, or horizontal scaling, vertical scaling. I'm not talking about all these things, because the main purpose of this video is just basic understanding of rate limiter, and also how to implement rate limiter by yourself, and also what are the algorithms are already presented in rate limiter. I will discuss all those algorithms. So first, when client hits the request, right, we have one service called client identification service. So let's say our service is basically software as a service, or let's say it's like user service only. There are two kind of services, right? One is like software as a service, or second thing is like basically a user service, like user based service. Like let's say all e-commerce applications you can consider as like a user based service, where we don't have any information, where we are not agreeing anything ourselves to the e-commerce application, right? Like say Amazon or Flipkart or Meesho, all these things. Second thing is like software as a service. So software as a service is basically we are providing these kind of features from our system to another system, to the other third party like company, let's say AWS or let's say Atlassian. These all things are basically called as software as a services. So where you have like okay, this particular client will have the privilege of using these many requests per second. All these configurations you have stored in your databases. For a client, for a user based thing, maybe you'll fix some default numbers, like say 10 requests per second. These kind of numbers it can be configured at somewhere. For a client, there can be client request ID as a request ID, which can identify uniquely by the client, of any client. For a user, it can be IP address, or it can be user. If it is a logged in user, right, it can be user ID. If it is non-logged in user, it can be accessed through IP address. Yeah. So whenever client sends the request, we should have in between we have client identification service. It has a single function called it has a single function check called allow request, that will if it is a success, if it is boolean is true, it will talk to our systems, our backend actual services. If it is not true, simply reject by saying HTTP 403, or like 503 service unavailable, or service is busy, or simply put it this particular request in the queue to serve in the after some milliseconds or some seconds. So these things are depending upon our choice, like how business driven. So this allow request basically this client identification service will call rate limiter under the allow request function. In the rate limiter service will basically fetch the rates from throttle rule service. Let's say I already discussed, right, like we have throttle database is there, which has a schema. Let's say client one has a 10 request per second. This kind of schema is presented inside the throttle database. So I think it's either system starts, or as periodically system will basically fetch the all data from the DB and put it in the throttle cache, so that it can serve a request very fast, instead of hitting the DB like a disk operation. So rate limiter service basically get the client throttle data from the throttle service. So it is like completely up to business what kind of algorithm it can be used. There are two popular algorithms currently presented. There are token bucket algorithm and sliding window algorithm. We can implement our own algorithm. It's completely up to us. So it will check like it will send that throttle rules to any of one algorithm. Depending upon the algorithm's response, either it is true or false, we will return the response to the client identification service. Depending upon that, it will either reject the service, or it will reject the request, or it will process the request. So this is about the clients. This is how like rate limiter will basically work. So now let's talk about like how token bucket and sliding window will work. So this is about sliding window. Sliding window is basically we have like time frame is there now. Let's say 0 to 1 second, 2 seconds, like 3 seconds, and so on. So this thousands basically denoted in milliseconds. So at any given particular time, at any given particular second window, maximum allowed requests are only 10. So at any given frame, maximum allowed request is 10. Um, this is about sliding window. So let's say like so in this particular second, let's say I have 10 requests, and in the same second I was trying to hit another request, right? It should reject, it should say as like request got rejected, yeah. If it is uh, let's say we have hit 10 requests per second, but slightly yeah, let's say we have hit 10 requests per second, but slightly this might got but slightly another request comes, it got uh, so if it is fixed window, right? So till 1 second, even though if it is 10 requests will come or not, it will only check those 10 requests only. If it is sliding window, right, every millisecond or every request comes, our window is basically slided, like whatever shown here, right? Next time yeah, next time our window will slide it to here, and next time again our window is slided to here. So every request window is basically slided, and it will remove like old request, and it will increase the it will remodify the window size. So this is like this sliding window will work like. So next thing is like basically token bucket. Don't worry, I'll show the implementation how it actually implement. Next thing is the token bucket. Token bucket is basically has like same thing, like configuration wise there is no extra change. Similarly, token bucket is basically we have one bucket is called, we have one bucket. Initially there are 10 tokens are there. Basically 10 requests can be allowed for this particular client. So every millisecond token count either may increase or either may decrease. If tokens becomes zero, right, it means like we cannot serve the request anymore. Then basically we need to refill the token at every request. Will get like by adjusting the time frame by checking the current timestamp, the or last refill timestamp, and depending upon how many time how much gap is there, we need to refill based upon the seconds, based upon how many seconds we need to refill, how many second frame we need to refill. So likewise token bucket will work either at max it can only have 10 tokens. So depending upon the time frame, it will be consistently around 10 tokens, or it might decrease it and become empty bucket also. If we get more requests per millisecond, like if the number of seconds are more than 10, we'll get the empty bucket size. It will take some time to refill again for the future request. So this is about token bucket. Um, so I hope you guys understand. Let's talk about like how to implement. Yeah. So so we have so we have different algorithms are there. So we have interface called rate limiter. And rate limiter has two kinds of rate limiter has single request called allow request. So this allow request implemented by different algorithms, leaky bucket, sliding window, or token bucket. So let's say we have before that let's talk about like let's talk about how our steps are there. So if we go to here, like client has like client identification request, it has rate limiter, it has total rule service, and it get the data from cache, right? So which means like initially we need to set up the rules, right? So for that purpose we have something called throttles rule service, which has like throttles rules cache is there. We can create the rules for the particular client. Since throttle rules is a particular model, it has like basically a bucket size and refill rate. Yeah, bucket size and also refill rate. And in the total rule service, we are storing all these things in the client throttle rules cache. So this is like singleton, like once we store everything for the if rate limiter service will basically get the will basically call this throttle rule service, right? We can simply access all the rules by accessing get client rules of particular based on of particular client ID. We cannot create every throttle rule service every time. It is a single time. Like from the next time onwards, we used to return the data whatever presented in the throttle rule service. So in the rate limiter service, we have something called client rule cache and rate limiter hash map, and also throttle rule service. So we'll talk about more. First thing is like we'll talk about main function. In the main function, let's say we have something called throttle rules, right? So in the throttle rules, by default, I have kept everything as like 10 buckets and refill it also 10 per second. I was fixed. So this is like completely configurable, right? You can change later at later point of time. I already discussed, right? There are two things are there. One is like SaaS based product and also like user based product. For SaaS based product, you can simply store everything in a database. For user based product, right, it is like generic way, right? You can store something in a configuration file, like let's say like this, like in some YML file or something. You can load that particular YML file through properties, through property load in any of language, like this also it will helpful. Or if you want to store everything in a database, you can store inside the database also by connecting this throttle rule service into the throttle rules repository. So as of now, everything what I was doing is in memory, right? I was just storing inside the hash map only. This is basically called as the cache. So user identification service is there, throttle rule service is there, and user identification service is there. User identification service has a single dependency called rate limiter. Will rate limiter basically has like is rate limited user request or not, depending upon the client ID. For SaaS based product, it's like client ID. For user based product, it's like user ID or IP address, anything. So this rate limiter has like is rate limiter user request is there. So first we check like, okay, if user is already presented or not. If it is not presented, we will create the user. If it is presented, we'll simply check like what is the previous refill rate and and previous tokens, or how many requests has served in 1 millisecond. If it is not presented, so we're calling another function called create user. If it is not presented, we have two hash maps are there: client rules cache and rate limiter cache. So first thing is the client rule cache. If it is so if user ID is not presented over here, right, we'll basically get the user ID from the throttle rule service. Here we'll so in the throttle rule service, user ID must be there, otherwise we need to throw the error. So so here in the client rule service, once we get the user details, right, we'll put it in the client rule cache, like user ID and client rules. So every time we no need to call the throttle rule service every time to get the user data. Simply we are caching in the rate limiter service itself. Next thing is like whether the user performed any activity or not, like user is any hit the API or not. Like if hit the API, like definitely will definitely the user has some rate limiter configured, right? That is we are checking like. So in the rate limiter hash map, user is presented or not. If it is not presented, we'll basically get the throttle rules. And also here we'll configure any kind of rate limiter. In the rate limiter, I was mentioned as interface, right? So these are like different algorithms are there, like token bucket algorithm or sliding window algorithm or leaky bucket algorithm. So currently I was using token bucket algorithm. You can simply put the you can simply create a object here, token bucket algorithm, and put it in the rate limiter hash map. So next thing is like you need to check like allow request. This allow request basically comes from this interface, right? Here I was implementing a class called token bucket. So in the token bucket, we have something called allow request. Now let's talk in depth about allow request. What is there in the allow request? So token bucket will basically contains max bucket size, refill rate, current bucket size, and last refill timestamp. So max bucket size is at a time how many buckets yeah. So let's say at a time, let's say we have 10 tokens will be there. So our max bucket size is 10. So our refill rate is also 10 per second. And also current bucket size, you basically keep tracking of like what is the current bucket size is there, like it should be less than or equals to 10 current bucket size. And last refill timestamp will require basically to compare with the current timestamp it will help for refill rate. And also this allow request should be synchronized. It should be thread safe. That's why I have kept synchronized one. So while checking this allow request, first we need to refill depending upon the client's last activity. In the refill rate, we should take the current timestamp and current timestamp minus last refill timestamp into refill rate by so here I was taking into everything into nano time. So you know about nano, right? It's like 10 to the power of 9, right? So if it is milli, it's 10 to the power of 6. So that's why I was dividing with the 10 to the power of 9. So let's say now we'll get some 1 lakh, like now is, let's say 10:37 p.m. So let's say here 10:30, so 10:38 4 seconds, right? So now can be 10:38 6 seconds, some 700 milliseconds, and previous can be 10:38 some 5 seconds, some 600 milliseconds. There might depend nanoseconds, yeah. Some 7,000 nanoseconds are there. We just simply like we are simply doing minus, and then we are doing into 10 to add the refill rate. So how many tokens we need to add extra, because of time shrink. um, Here let's say if you're getting every request in the same second rate, then this now minus last refill timestamp becomes 0 every time, right? There is no tokens to add. If you're getting a request after some milliseconds or some microseconds or some nanoseconds, we will get some value here. We are multiplying into refill rate, and then finally we need to divide it by 1e9 because it's per 1 second. So we are just printing, okay, before refill, this is the token bucket size, and already discussed, right? At a max, token bucket size should contains only 10 tokens only. Like it shouldn't exceed the max bucket size. That's why we're checking, like, okay, take the minimum of either max bucket size or current bucket size plus how many tokens to add. Let's say we have five tokens are there, and tokens to add is like 3. So we'll take like for a next serve request we have available of seven tokens extra. So we are printing after refill how many tokens are available, and we are need to set back the now time last refill timestamp to current timestamp, whatever now is there here. So this is about token bucket algorithm. Like it is a very simple algorithm. It is just checking depending upon the last timestamp and the current timestamp, and it is refilling, and simultaneously it was adjusting. So once we refill, right, here we will check, okay, after refilling, if current bucket size is greater than 1, so if it is greater than or equals to 1 basically, which means like we can able to serve the particular request. Then current bucket size, we need to decrease the current bucket size. It shouldn't go to the 0 or negative, right? Then only we will return the false. We simply rejecting that particular request. So similarly, let's discuss about sliding window also. So token bucket sliding window is basically name itself is there. It's there a sliding window, which means like it contains all the requests in a window, right? Window is nothing but a queue. So that's why we have something called a queue. We have implemented concurrent linked queue, which is like thread safe linked queue. Initially, what is the bucket size? Let's say 10 bucket size, and the time window in seconds. It can be 1 second, or it can be 2 seconds. Okay, 10 requests per second or 10 requests per 2 seconds. It is completely configurable thing. So whatever data is fetching from our DB, we can simply put it over here, like. And this also should be thread safe, right? And that's why we keep it as synchronized. So here also same thing, for allow request we first take care about current time. Here we're taking about current times in milliseconds. So we're checking, okay, we check and update the window. How we checking means, I already discussed it, right? We have at every time frame, it should be the window size should be, we need to refill the window size such that just we need to refill the window size, like. So here if queue is empty, we just simply return, like, which means like there is no values inside the queue, which is like empty, which means like it can be allow, like, for future request. So so we have current time is there, current time minus q dot peak, right? If you know about q dot peak, which will gives the timestamp. So here in the queue we need to store the all the timestamps, so that in the queue, I think you guys you know about queue, right? We have front, and also rear is there now. So one is basically back, and one is basically front. So we need to so queue is like basically first in first out, right? So first in first out means like what is the last timestamp inserted, what is the timestamp inserted in the queue. If it is that is basically the last timestamp, that is the least timestamp, right? That's why we're basically getting q dot peak minus current time. So if it is so we have current time is there, current time minus q dot peak, which will gives the all the timestamps. So similarly, by 1000, because it is we are considering in milliseconds. If we put nano, right, it is like 1e9 as we did in the token bucket only, like. So we're printing the time. So if queue is not empty and its time is greater than time in seconds, like suppose if the difference between the let's say peak time and also current time, which is like less than 1 second, right, then if it is like basically greater than 1 second, right, then we need to remove the all the least timestamps, which is responsible, which is basically wrong, right. Our system should our maximum timestamp difference should only get the 1 second, like whatever configurable thing here, like that's why we keep on polling the queue. From the all the last values will all the first values which are inserted will keep on becoming poll. Let's say a simple example. Hmm, let's say first is inserted at, let's say, 0.1, and second is inserted at 0.2, third is inserted at 0.3, and fourth is inserted at okay, q is basically first in first out, right. 0.1, 0.2 is inserted, 0.3 is inserted, and so on, like let's say 1.1 is inserted, like let's say inserted, like. So this is like a q dot peak value 0.1, first in first out. We need to poll. So current time is basically, let's say, 1.1. So till 0.9, till 0.9 it is there. We are trying to insert let's say 1.0 is there. They are trying to insert the 1.1 value. This 1.1 minus 0.1 is like this is like 1.1 minus q dot peak value is like 0.1, right, which is basically 1.0. Let's say if you configure time in seconds is like 1.0, right, like which is if it is greater than if it is like basically 1 second, because it should present 0.999 seconds it is allowed, but 1 second is not allowed, like we need to remove that that least inserted value, like that's why we are polling the value. So q dot 0 will be removed, and the next time we'll get the answer as like instead of 1.1 minus 0.2, which is basically 0.9, which is like less than which is basically acceptable, like time value which is basically less than the time in window seconds. So we are out from this while loop. Otherwise we'll keep on pull and we'll keep on update the current time value and keep on checking, like till we have exact window size is like 1 second, like time window in seconds available. So after this particular updation is done, then we quickly like queue size is less than bucket size, we'll simply offer the current time. So that one will basically inserted after here, like 1.1. So next time it will keep on checking, like will return true. Next time for next request it will keep on check this window, whatever data is there. So likewise the sliding window will work like. So these are the two popular algorithms currently presented for rate limiter. You can implement combination of sliding window and token bucket. It's like completely up to you, like how you want to restrict it with your user, like. Now let's say how to like let's say how we can simulate this one to know really how it is happening, like. So first one is like throttle rules. So once we configure rules, we'll get the instance, singleton instance. Next thing is like we'll create the rule. Once we create the rule, right, so next thing is like this job is done, like. Next thing is like user identification service, like. So this is happening at the back end, like either for SaaS based product or for user based product, right. It's like basically a default thing which is in the configuration file. And in the 15th one, and here it has like user identification service is there. So it has simple called request.serve requested, as we already discussed it, like. It has a rate limiter, and rate limiter to throttle service. It will execute any of the algorithm and it will return the response. If it is true, we'll printing request served. Otherwise, we'll printing too many requests. Please try again. So here I was simulating with the help of threading. You know about executors in Java, right? Either you're in any of the stream, either in Java or Python. It doesn't matter. Like if you know about threading in your respective languages, like. So in Java, it has like executors are there. Executors is something we can schedule. We can schedule the execution of anything, like we have one function is that print hello. we can schedule that one at certain seconds, like at every second we can, after certain seconds that particular function will re-execute every time. That is what schedule thread pool will basically take care about. Like I was initializing with the 5 threads. uh, so what I was doing is like I was creating some small runnable. This is like basically lambda function. Like in the traditional Java, you'll basically create a new runnable, all these things, right? Uh, New runnable, inside we have something called run function. Everything will be there. You override that run function, all we do, right? So in the normal lambda function, you can simply given, because this is like a function interface, which is like anonymous function we can implement. So it will basically print this one and will keep on calling it will keep on call only this particular function only, like. So we are scheduling this particular function, let's say at every 100 milliseconds. So this function is hitting at every only once at every millisecond. So which means like what is our expectations? This function, this one will not, it shouldn't be terminated like at any point of time, right? We shouldn't get the every time we should allow, like if you run this particular program, right, you'll understand, like at every 100 milliseconds we are basically allowing that one particular request, right? Which means like for 10 milliseconds, nothing but 10 seconds we're allowing 10 requests. There is no wrong, right? So that's why every time you're seeing requests served only, nowhere you are seeing too many requests are there, please try again, these kind of messages you're nowhere seeing, because bucket is consistently refilling at every time. It was not reducing, right? Now let's see, like um now instead of this one, let's say you have hitting like every 50 milliseconds, you are hitting one request, which means that per second you are hitting 20 requests, right? Which means that you are expecting a rate limiter through rate limiter should work, like it basically rate limit some of the requests it shouldn't allow the request, right? You can simply simulate that one also. For initial first 10 requests, it will not throw any error. From next time onwards, it will throw till the bucket refilled. After that one, it will allow. Again, it will throw till bucket refill. You can see that one here. Like it will go a bit fast, I think. Yeah. First is request served. First is requesting serving. At this point of time, our bucket size is becoming 0, which means like too many requests. So if you see, right, like at last every time it was serving the request and consistently getting the too many requests, like serving the request and consistently getting the too many requests, like. So every time our rate limiter is basically throttling the system, like. And also if you clearly observe our bucket number becoming 10 or 9, because at every millisecond we are hitting twice a request, right? That's why we are facing the too many request error, too many request so if we, let's say if you put 10, so we will see most of the things are just ignoring, like it will not process request served, everything will be error only, like everything will be try again function only, like if you see initial, like if you see, right, so almost a single around for 10 requests only single one is processing, right? Everything is getting like too many requests only. So because for a millisecond itself we are for a single millisecond we are allowing almost 10 requests per second, like. So yeah, that is the basically issue, like for a single millisecond. So this is like 10 milliseconds, right? So which means 1000 milliseconds, 10 requests, right? So that's why yeah, 100 milliseconds means basically uh, uh, 10, so if it's 1000 milliseconds, right, which is basically 1 second, which is like perfectly fine, right? Our system can capable of even more, like instead of serving one request per second, our system can capable of serving 10 requests per second. That's why we are requesting one request per second, like 10 requests per second here, and here is like basically 100 requests per second. So in the 100 requests per second, like 90 requests should be failed, like. So this is all about like token bucket. Like I think through the role service in rate limiter service, if you change to the sliding window, then also there is no much difference. Like it is still works fine as it is. There is no I think I changed the. Yeah, I have kept 10, right? That's why we are seeing too many requests. Like, if you put 100, then it's fine. Like, so everything is request served. Some are becoming too many requests. Like, so again request is serving. Like, so because we are in that particular time, right? It is keep on serving, and again it's too many requests. Like, let's say if you keep 1,000, right? Then I think we didn't face the issue. Like, so every time it's request is serving only. Like, we won't get like too many requests. Like, you can try. Like, I will anyway. I'll put this link in put it in Bitbucket. No, sorry, GitHub. You can view over there. Like, you can modify different algorithms and you can try yourself. Like, so in a single time tree, like we got three requests. Yeah, so it will work exactly. Like, just understand like how sliding window will work, and also token bucket will work, and also to play around with, just try, just modify here, like whatever algorithm you want to use, and then simply execute main service. It will work. Like, this is all about schedule. We can execute all about how to simulate this rate limiter with the help of new fixed thread pool. We can also do like we can also do with the help of executor service, directly creating 10 threads, and you can run in the for loop. Let's say you have run this in the for loop. 1 second, I was cloning. So here, how much we need to wait? Let's say 100 milliseconds. So you're not. So this is basically. So if you see, right, this one is basically not very concurrent, right? Like, this is basically something called concurrent. Like, so in the for loop, you're executing you're executing different threads at a time. So this is something called concurrence. Even though concurrent threads are coming, but you're not seeing a request is like too many requests, um because like it is capable of serving 10 requests per second. If it is, if you put sleep is 10 only, right? Then we might see some are like basically try again issues. Like, okay, request served, everything request served. I think because of so we have many threads are there, right? Let's say we restricted our threads like concurrency to 10 threads only. Like, so because of 12 threads are there, all 12 threads are taking this for loop, and it is executing. So let's say if you decrease the number, then definitely you will see some requests are being try again. Like, some requests, let's say. See, this one is basically try again. Like, so depending upon the number of threads are active. Like, so here basically one thread is there. We have around 12 concurrent requests are there. I think 12 concurrent requests are there, and 10 got in the 12 concurrent requests for a single thread. You can understand, like, okay, 12 or 10 requests should only allow read, 2 requests should get the too many request error. Like, so it was allowing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It is allowing 11 requests, and 12th request getting too many requests. Because why? Because for all the 12, for all the for loop in the 12, right, we are putting thread dot sleep 10 milliseconds, which means like 12 into 10, which is basically 100 milliseconds. So system is sleeping 100 milliseconds, which is responsible of executing the 11th request, and the 12th request is becoming failure. So if you suppose if you commented this sleep function, right, if you just execute, then you should see two requests are getting failed instead of one request. See, two requests are getting failed because of this thread sleep function. We are seeing one request is getting passed. So these are the two different ways you can play around this one. One is like fixed thread pool. Second thing is like scheduled thread pool. Executing a thread at every fixed second, every fixed time. This is like executing all the threads concurrently, like with the help of a different n number of threads, like. So this is all about like a rate limiter one. Yeah, I think I'll post the link in description of code everything. In future, I was trying to upload a lot of machine coding rounds, which I was faced like Facebook, mini Facebook machine coding round, like low level designing. All these things will upload future soon. So please subscribe, please like and thumbs up for all the future videos. Yeah, so that please support us. Like, yeah, thank you.